I can choose you, and then you unmute, and then you are able to give your you're able to give your answer. Okay, you're able to give your answer, and then we can continue. Now, for some of you who have just joined us, of course, always for each lesson, I try to review backward, but I don't waste a lot of time. With this topic, we began midway in the previous segment of the pilot study, uptake and transport of mineral salts, where I looked at diffusion and I told you what it is all about and active transport and everything involved. And then we're able to look at some of the graphs which are examined, either paper 1 or paper 2. Remember, biology has 3 papers, paper 1, 2, and then 3. So paper 1 and paper 2. And then I was able to expound much on all these graphs. And to actually make it to wind up that topic, we were able to even look at last year's UNEB question, which is P530/2, and how it was supposed to be tackled. This was last year's UNEB question. It came from this topic. So here he's saying, sir, help us with notes for reference. Notes, I uploaded these notes time ago in Google Classroom. And but normally for A level, I always encourage students to get textbooks and read from the textbook so that you are able to be somewhere. That is what I always encourage. But in case some of you are lacking, I'll again upload more of these notes. I will upload them, no problem. But I had already uploaded them. So for today, our main theme is going to be basically on transpiration. You guys have studied transpiration ever since you entered P7, not P7. Is it from P2, P3, then you went to all doing the same thing. So the transpiration is all about evaporation of water from the surfaces of the plants, especially the leaves. And you can see this is a picture of a leaf. Yeah, it's not like it is sweating, much as you looking at it as sweat, but this is just water vapor that has just left the leaf surface, which we are calling transpiration, into the atmosphere. Okay, so this is the evaporation of water from the surfaces of plant leaves through the open stomata. This is where the plants in the stomata, this is where the plants lose the water from them. And of course, they are found both on the lower and the upper parts of the leaf. But of course, for most leaves, a leaf is called a chicola in Luganda. So for most of these leaves, they will have underside, because the leaf will have the upper part as well as the lower. So for most of those stomata, they're going to be found on the lower epidermis. And when you look at a leaf, you can't actually see them using your naked eye. You actually need to get a very thin slice or thin layer, which you peel off from the underside, place in a microscope, and then you're able to see the stomata. Now, the evaporation of the water takes place through the cuticle of the epidermal cells. That's these are cuticular transpiration. Okay, cuticular from cuticle, that is cuticular transpiration. So there are very many factors which we are going to look at. Among them, which affect transpiration rate. And I think you know the meaning of the word affect, factors that affect those conditions which may either increase or decrease the speed at which the plant is going to lose water. And the first one is light. This light, which normally is due to sunlight in nature, but of course sometimes we can actually control light by putting a plant in the dark, and then we just use artificial light like a bulb. You switch on a bulb or electricity. Here, we know that transpiration actually is going to increase in bright light. But why? Have you ever asked yourself, if we are saying that transpiration is going to increase in presence of light, why? What does the light have to do? What does the light do that makes this plant to begin losing water more often than in the dark? Muchizikiza, okay? So the stomata open wider. So that means light has an effect of opening the what? The stomata. So the stomata open wider to allow more carbon dioxide into the leaf for photosynthesis. Normally during the day when there is too much light. Now more water is therefore able to evaporate. As the plant is trying to take in as much carbon dioxide as possible to make more food during the day, it also loses water. Then another factor is actually temperature. Another factor is temperature. So would you even imagine, imagine yourself, imagine you are a plant. When do you normally sweat faster? Is it cold? But no, but that example may kind of confuse you. But transpiration is faster in higher temperatures. Why? Evaporation and diffusion are faster at higher temperatures. Why? So we're going to expand more on some of these. Another one is wind velocity, the speed of wind. Wind means air which is moving at a faster rate. That is what they call. Where does it come from? Is there a machine that somewhere in the corner that makes wind? For some of those, you could just make some personal research. Where does wind come from? Just to know, instead of just saying wind. So wind, transpiration is faster in windy conditions. That is when the wind velocity means the speed at which wind is now going to be moving. So water vapor is removed quickly from the air by air movement, speed of the leaf. We shall be talking about this more in more detail. Another one is humidity. I think you've heard of what we call humidity. Now, transpiration is slow, whether you guys know the meaning of the word humidity, because some of these are exact English words which we have learned right from primary school through O level, and now we are at A level. Now let us go and begin understanding one by one in detail. So these are the environmental factors affecting rate of transpiration. I told you that the meaning of the word rate just means speed at which something is actually happening. So these factors may either speed up or slow. And what are we slowing? That is the rate of transpiration, which transpiration is the loss of water from the leaf surface. Okay. And remember, losing water is key, is a very much important, or retaining water is a much important factor, especially when living organisms crossed from being in water to staying on land. Because as a matter of fact, life evolved from the water, and now living organisms, which included plants and animals, started living on land. So when they came on land, they faced a challenge of retaining water because there was scarcity of water on land. So when we talk of environmental factors which affect the rate of transpiration, it means this is important because if you're a plant, you don't need to lose water more often, since water is one of the most important substances that make life possible on land. So the first one is temperature. I've already told you that we are going to be expounding more. Now, a high temperature provides latent heat of vaporization and therefore encourages evaporation of water from the mesophyll cells. Okay. So when you look at what does temperature actually do? What does temperature do? One, temperature is going to, when temperature increases, this arrow means increase. So when temperature increases, it means it increases kinetic energy. So also kinetic energy does what? Increases. Okay. And I think you know what kinetic energy is. That is energy possessed by a body by virtue of it being in motion. Okay, that is kinetic energy. And when kinetic energy increases, those are maybe the kinetic energy now, in this case, the water molecules, the rate of diffusion through the stomata pore is also going to increase. Are you seeing how you explain this temperature thing? Now, then air is able to hold more water molecules at higher temperatures also. And also the rate of transpiration, does what? Increases. And you can see here in this graph, which is simplified, on the vertical axis, you're having rate of transpiration. On the horizontal axis, you're having temperature. So as temperature is increasing, the rate of transpiration also increases. And why? You know that that temperature increases the kinetic energy of, and so they will move through the stomata very fast. Okay, and also another influence is that more water molecules at a higher temperature increase. Then another fact is rate of humidity. With the humidity, you're looking at the degree or the extent to which the atmosphere is saturated with water vapor. The word saturated just means filled up with something. Okay, to be filled up with something. So is the degree to which the atmosphere vapor, because if the atmosphere has a lot of water vapor in it, it means that a lot of water vapor is going to be surrounding this the leaf. Just imagine, okay, let me get a blue here. Just imagine water vapor is everywhere. I'm just assuming water vapor, I'm just saying this is a leaf. Now, because there are pores, which we call stomata, water may not move out in case there's a lot of water vapor surrounding this. It may be hard due to a very low concentration gradient. Okay, so water may not easily diffuse from the leaf to the surrounding, since it is being blocked by the water vapor molecules which are close to the leaf surface. They may block it. So the rate of transpiration may be extremely low. But in case there was no water vapor, that would create a very steep gradient. For some of you who do not know the meaning of the word gradient or concentration gradient, as we normally put it, concentration gradient. Concentration gradient. Now, gradient just means, just like in mathematics, you know how the things of maybe getting the gradient or calculating the slope, which we normally do like this. Okay, gradient or concentration just means that one end is extremely having more of something than the other. So if it were a beam balance, okay, like this, so it would be kind of slopey like this, slanting, whereby you're having, if there were molecules, more of one molecule on this side than the other side, with almost or virtually nothing this side. So creating that what we call a slope, or in these times we call it concentration gradient. That's what it means for some of you who didn't know. So with concentration gradient, just means that one end of a membrane or on one side is more of something than the other side, okay, which may have like over 2 or none at all. I hope you've got it. So the degree to which atmosphere is saturated with water and it determines the saturation deficit. That is the difference in humidity between the inside and outside of the leaf. Now, in this case, the inside of the leaf is going to be having what? Water which wants to escape. But in case it finds there's a lot of water vapor outside, so there is no concentration gradient. So it will be hard for this leaf to undergo transpiration. But in case this leaf didn't have any water vapor or humid around it, that there would be a high concentration gradient. That is, inside the leaf, there is more of the vapor which wants to escape, or the water that wants to escape, and outside there is nothing. So it creates a high concentration gradient whereby the water vapor will move from inside the leaf to outside where there is none at all. Okay, due to a high concentration gradient between the inside of the leaf and the outside. Okay, so that's what it means. Then, and you can see here on this curve graph, where you the eraser. Yeah, you can see on this graph we are having effect of humidity on plant transpiration. So suppose such a graph, actually such graphs normally come in paper 1. So here you're having that when the humidity, I'm now reading this horizontal axis here. For some of you are not looking at it, this is where I am. When the humidity is extremely low, look at what is happening to the rate of transpiration here. It is extremely high. For some of you are not getting it, you could have from 0, if I can put values here, 0, 10, 20, 40, 60, and let's say 80. And then here I have 0, 5, 10, 15, 40. Are you seeing that? So when the humidity is 0, check the rate of transpiration is at 80%. That means there's a very high rate of transpiration. That is, there is a very high rate at which a plant is losing water. But as humidity is increasing from 0 to, let's say, to 0, okay, let me begin from 10 to 40. Check what is happening to the rate. The rate is actually decreasing rapidly. The rate is decreasing rapidly because because of the lowering of the concentration gradient, since there are more water molecules that are surrounding the leaf surface. So less water is going to be lost from the leaf surface to the atmosphere. And I hope that is very clear. Then another one is air movement. Air movement, the immediate surrounding of the leaf, if it is highly saturated with water vapor, okay, if it is high, remember, saturated means to be filled up with something. So if it is highly saturated with water vapor, so Emerald is saying, so why doesn't it 0? What do you mean by why doesn't it 0? Which one are you talking about? Which one? This one? Are you talking about the rate of transpiration in this case here at this moment? Okay, I don't know, Emerald, which question are you asking exactly? Okay, let me see. Emerald is saying yes, meaning that here, according to this graph, of course, it is in nature. If you're looking at the plant leaves, okay, of course, the plant leaves cannot, like, it is very hard for you to have the atmosphere fully saturated with water, okay, like dew, in case there is dew. For some of you who don't know dew, olufu, olufu, in Luganda it's called olufu. When there are times when the environment has like almost, you can even see the water vapor surrounding the environment, when there's a lot of dew, that's a very high humid condition. Even if it is like that, remember this leaf surface can have up to 500 stomata. 500 from 100 to 500 stomata on the underside, or even 5,000 stomata. So it is actually impossible that water may not escape. So some water, of course, will escape, but at a very slow rate. At a very slow rate. You get it? I was still telling you that the air movement, the immediate surrounding on the leaf is highly saturated. If it is highly saturated with water vapor, the saturation becomes less as layers of water vapor called diffusion shells diffuse away. Okay. Normally, a leaf will be like so. And I'm assuming you're having some stomata here on the surface, the stomata there. So normally they are what we call diffusion shells. For some of you who want to know much about it, you go to a book called Advanced Biology by Simpkins. It kind of elaborates more on what we call these diffusion shells. It's just like from, if I can use an example, let's say a leaf, from close to the leaf surface to around somewhere, the amount of water vapor that is there is kind of slightly more than if you continue upward a few centimeters and a few centimeters and a few centimeters. Those are what we call the diffusion shells upward, meaning that the concentration of the water vapor keeps on dissipating or disappearing as you move far away from the leaf surface. So close to the leaf surface where the stomata are, that's where we have the diffusion shells. So if they are allowed to build around the leaf, the rate of transpiration in the mesophyll cells does what? It decreases. That means in this case, there is going to be almost still air, no air. There is like, have you ever been in a place whereby you can't feel any kind of air that is blowing on your skin? That is the situation that I'm talking about. But in case you are somewhere, normally there should be some air that is blowing. So normally when water vapor builds around the leaf surface, creating what we call diffusion shells, some air is supposed to come and blow away those water molecules so that more can escape from this stomata. Look at this graph here showing rate of transpiration, here wind speed. And you can see that as wind speed increases, rate of transpiration also increases. Okay. Why? Because wind blows away water vapor around the stomata, creating a steep concentration gradient. And I've already explained what we mean by concentration. Then we can go to atmospheric pressure. Now, atmospheric pressure, I don't know whether you guys know what I mean by atmospheric pressure. Pressure just means a force which is acting on something, okay? I think you guys have heard of someone saying, don't put me on pressure. What do they mean when someone says, don't put me on pressure? It means don't overpress me. You are pressing my nerves. You get it? So when someone is putting you on pressure, it means they're putting some force on you. Likewise, our atmosphere is actually acting on us, although you guys are used to it, that you don't feel it. Actually, what happens is that above the Earth's surface, I'm assuming this is the Earth. Earth means NC, and I'm assuming we are here. This is Africa. This is Africa. And for us, we are here in Uganda, there. Now, I want to zoom into Uganda a little bit. When I zoom into Uganda, okay, and I'm looking at you seated here. You are just, okay, you are squatting there. Mabonga Isaiah says, why does the graph of wind speed begin? Why does the graph of wind speed begin from 0? Now, Mabonga, these are the same questions which I've already, this is the same thing which I already answered back here. Of course, wind, why does it begin from 0, in your own opinion? Okay, why so? Maybe as you are thinking about it, let me first continue explaining this. Now, if you are here, and I'm assuming the sky is up, the sky is up. Did you know that you have a full 1,000 kilograms of air seated on your body? 1,000 kilograms of air, kilo lukumi, 1,000 kilograms of air that is pressing against you. Much as it is air, but you can't feel it. You can't feel it. Okay, that is pressing against you. But if you want to know the effect of some pressure, you just go and begin swimming. You go to the water and begin swimming in a pond. When you dive, I'm assuming this is water in a pond. Water is there. When you dive and you are inside there swimming, you are there swimming and you are diving, you will feel some kind of pressure on your ears, or will you try to press against your ears? You feel some kind of pressure. So you can feel that in the water, because water, of course, is a different medium from air. So because for you are not used to being in water, so you will feel that pressure exerted on your body by the water. But when you come out on land, you are used to it. Okay, so that is why if there is someone on a mountain, okay, let me first erase off this. If there is someone on a mountain, because air comes from is seated on us, so when the lower you are on the part of the earth, when you are so low, then the more pressure that is on you. Okay, here. Okay, so for someone who is in a lowland, okay, someone who is on a lowland, you're going to be experiencing more pressure. Someone who is up a mountain, okay, you are going to be experiencing less pressure because less air is above you. Less air is above you. That's what we call atmospheric pressure, which is due to the air pressing against us. Okay, so that's why I'm saying atmospheric pressure decreases in the mountain areas. There is low atmospheric pressure, so evaporation is going to increase because there is less pressure acting on the leaf surface. So a plant which is on a mountain will evaporate more than a plant which is on a lowland, because the one on the mountain is experiencing less atmospheric pressure, less air is pressing against it, and the one which is on a lowland is experiencing more pressure against it. So water vapor pressure decreases with decrease in atmospheric pressure, resulting into greater rate of what? Transpiration. So higher altitudes have low atmospheric pressure because less air is above them to press against them. And plants growing in such areas are liable to a very high rate of transpiration. So a higher atmospheric pressure increases the water vapor pressure and reduces the rate of transpiration. I hope you guys have gotten it, because this thing normally disturbs very many people. And then, if you have understood, I have some small graph here. This graph is showing the correlation between the rate of transpiration of oats and light intensity. It was, of course, adapted from Sutelif in 1968. Is the one who generated this data, and this data was done. I don't know, first of all, whether you understand which factor that affects the rate of transpiration this guy was investigating. I don't know whether you can understand. This is okay. Let me write the word here, a small quiz. quiz. Now, I decided to bring these quizzes of this topic to come from mostly paper 2, because paper 2 disturbs very many candidates and they end up getting 0, and someone gets, let's say, a ditto C3 in paper 1, they come with F9. Can you imagine in paper 2? That's very terrible. That's very terrible. So first of all, you must understand this graph, which factor that affects the rate of transpiration is this graph kind of looking at? Have you identified it? If yes, can you explain? Can you describe this graph? Of course, I'm not going into description of these graphs because we did it last time. So I don't need anyone to do what? To describe it. But we could try to explain. Look at this. I told that whenever you're given such a graph, first read these words, the preamble words. Then read the words on both the vertical as well as the horizontal axes. Okay. And then afterwards, read what each line or a key that is provided for that graph. Now we are here on this graph. On the vertical, is this side of the left is showing transpiration as measured in per hour per plant. Then solar radiation in joules per centimeter squared per minute. Okay. And then we are having time of day per hour here. And this dotted line showing solar radiation. Radiation, I think you know the meaning of the word radiate. That is, it means something that moves from a given point, dissipating in different directions. That is to radiate. So in this case, solar means the sun. So that means this is like the sun's rays from the sun, rays that are coming from the sun. Then here we are having the rate of transpiration. And then here we are having the time of day. So can you kind of explain this graph? Can I have someone say something about this graph? At least explaining from, let's say, from 0 to the 4th hour. Okay. Then from the 4th hour to around here, around this hour. Okay. And then to around midday, to around 1 here when you have maximum. A maximum is around midday here. So can I have someone raise their hand and then you comment about it? Who has seen it? You are using knowledge which we have studied previously in the previous slides. So who can try to explain this graph? Yes, Sherry. Okay, let me unmute Sherry. Sherry?
I'm giving my point. Huh?
Yes.
So I think from 0 to 4 hours, it says, I think, okay, this has something to do with temperature.
Sherry, continue.
And I say I give up.
But Sherry.
Yes.
In the graph, there is nothing like temperature. You first deal with those factors which you are seeing on the graph. Right. Yes.
Transpiration. I'm with you.
Okay, Sherry, I think you have run away. I'm seeing Emmanuel Emarot. Yes, Emmanuel.
So what I think, from at 0 hours, the rate of transpiration is at 0. This is because the sun has not yet come out. And you all know that the rate of transpiration depends on the light. Then from 0 hours to 4 hours, the rate of transpiration increases gradually. This is because the sun has started coming out. And so it starts increasing gradually.
Yes.
Then we can see that from 4 hours to 12 hours, that's midday. The rate of transpiration increases rapidly. This is because the sun is already out, and like let me say the temperature also increases. That's the kinetic energy, let me say, between the leaves also increases. That's the rate of transpiration increases. Then towards the end of the day, from 12 hours to 20 hours, the rate of transpiration starts to decrease gradually. Let me say, it's rapidly actually. That is because the sun has, that's because the sun has started to set. No? Yes, and that's the rate of transpiration lowers.
Okay. Thank you, Emarot. I like some aspects of your answer, but although I need a real reason why the rate of transpiration is increasing rapidly. Is it because of temperature when the sun is out? Is it because of temperature? Let me choose, I'm seeing here, Raymond Omenya. Yes, Omenya. When I ask you to unmute very fast and you go on. Omenya. Omenya has failed to unmute. Let me get another person, Joshua. Yes, Joshua.
Yes, teacher.
Yes, go on.
I can answer it based on humidity.
On humidity?
Yes. As I say that from 0 hours to the 4 hours of the day, that is in the morning, and the humidity in the air is still very high, and the sun has not yet come out clearly, so the rate of transpiration tends to increase gradually. And from 4 hours of the day to 12 hours of the day, which is midday, the sun is already outside, and it has already dried out the humidity which was in the air, and the rate of transpiration tends to increase rapidly. Then from 12 hours of the day to around 16 hours of the day, that's where we have the highest amount of sunshine. The sunshine is open on the day. It is very sunny, so the humidity has already dried up, and that's why we see that rate of transpiration is at its maximum. Then from 15 hours of the day to 20 hours of the day, we are seeing a gradual decrease of transpiration, because the sun has started to set into the west, where hence the humidity is now increasing gradually in the atmosphere. Then between 20 to 24 hours of the day, it is generally at night, where the humidity in the atmosphere is very high and the sunshine has already set. So hence the decrease in transpiration, and finally and hence there is no transpiration at around 24 hours.
Okay. Thank you for that contribution, Joshua. We are going to merge all these explanations. I'm seeing Arthur. Arthur, can you say something very fast?
Yes, teacher, I'm going to explain according to light intensity. So from 0 hours to 4 hours, transpiration rate was low, increased gradually, because there was less light intensity. And from 4 hours to 12 hours, the rate of transpiration increased rapidly due to an increase in solar radiation from 400 to 2000 joules per centimeter infrared, because this increased the light intensity, and that the stomata opened more wide to let in more carbon dioxide, hence increasing the rate of transpiration. Then from 12,
I like Joshua, are you hearing?
Arthur.
Joshua? Sorry, Arthur. Hey.
Yes.
Arthur, I like that aspect of that you have brought in light intensity affecting or making the stomata to open.
Yes.
Because actually, for the last previous, I want us to combine all this information that each one is contributing. Now, Arthur is bringing an aspect of the stomata opening, and they open just to let in carbon dioxide, but at the same time, also water vapor is being lost. So I like that aspect. Guys, take note of that. Arthur, you can continue.
Then from 12 hours to, let me take it up to 20 hours, the rate of transpiration decreased rapidly, because the solar radiations also decreased from 12 hours to 20 hours, because the sun is also setting, and this decreased the diameter of the stomatas. And when the diameter of the stomatas are decreased, the rate of transpiration or evaporation of water also decreases. Hence, the respiration rate decreases rapidly. And from 20 to 24, the rate of transpiration decreased again gradually, because of low solar radiations, or low solar radiations, and the stomatas were closed, hence reducing the rate of transpiration.
Wow. Thank you very much, Arthur. I think well to Arthur's answer, because for a plant to lose water by transpiration, it means the stomata must open. But in this case, what is making the stomata to open? Solar radiation. So I like Arthur's answer very much. Okay, and we can take it on, but for paper 2 type questions, you can as well add in more other factors, because some of these factors, if a question came like this, okay, let me first comment about Arthur's answer. There's even one time they set a question whereby they were looking at light intensity with the transpiration and stomata aperture or stomato aperture. Stomato aperture, that means, okay, let me write the word stomato aperture. They're looking at, sometimes you can see that the stomata beginning to open, and so the rate of transpiration when the stomata aperture is still so much, the diameter in between in the aperture is small, then the rate of transpiration is low. But when there is maximum light intensity or solar radiation, then the stomata are fully open, so you're going to have a very high transpiration. So I like that kind of thinking. But for paper 2 type questions, sometimes when you see you're having a graph, it is normally an open thing. So some of these factors can actually be talked about all through. For example, when you talk about light intensity, okay, and how it is going to affect stomata aperture, then you can also bring in an aspect of temperature and as well as humidity. So all these ones, you can actually intermarry them. But for the case of this graph, you could look at it as Arthur has looked at it. Let me read some of these answers, which some people had written. Wahereza Emily had said that from 0 to 4 hours, the rate of transpiration gradually increases with the increase in solar radiation, which gradually increases the kinetic energy at which the water molecules are released. This increases, this includes in transpiration. So you also have something. And then Emerald says, I think this whole thing is on temperature. Emerald, it's not only on temperature, my friend. It's not only on temperature, but you have seen solar radiation. They have a very much effect on stomata opening, as others put it. Then the teacher says, the teacher, what about between 4 hours to midday? The solar radiations are high. That's rapid increase in the rate of transpiration. Now, Letitia, when you say solar radiations are high, that's increased. There you are leaving it open. So you have to tell us, what do the solar radiations do that increases the rate of loss of water from this plant? That is what others just said. That's increase in solar radiations. They bring about opening. That means there is high light intensity, which increases the opening of the stomata, and so water is easily lost, which increases the rate of loss of water from the plant leaves. So I think you guys have gotten what we're looking at. So you can look at this, that light intensity affects transpiration by controlling the degree and to some extent the pattern of stomato opening. You can get this from this information. I think Arthur had read some textbook. That's why I always encourage people to read textbooks. They give you clues and you become better than someone who's just waiting for notes and all those things. And you can see that I got this exactly direct from the textbook. I didn't change anything. I got it from the textbook. So light intensity affects transpiration by controlling the degree and to some extent the pattern of stomata opening. The stomata of most plants open fully in daylight hours, bringing the saturated air. And now, are you seeing that now you are bringing in another aspect? So bringing the saturated air enclosed in a leaf into direct contact with the surrounding atmosphere. This is why there is usually a close correlation between the rate of transpiration and light intensity. So exceptions are succulent xerophytes. Now, these xerophytes are normally grown in arid areas, okay, such as cactus, whose natural habitat is the desert, okay. They close their stomata in light, thereby minimizing transpiration in the hotter parts of the day. And then Joshua is saying, teacher, which textbook? I got this from Advanced Biology by Simpkins, if you can have access to it. Okay, then I think you guys have been able to answer this question just by your observations, and I thank you guys and the different contributions which you have brought in. Then we can go to the next. Light intensity does not directly affect the rate of transpiration, but it causes the stomata to open, thereby the stomata closing the dark conditions and opening light. So the rate of transpiration is greater under light intensity than low light intensity. So in case such a graph comes in paper 2 or paper 1, you are able to tackle it. Then water supply also. Now water supply, you're looking at transpiration depends on the walls of the mesophiles getting wet. When the walls get wet, so the plant needs adequate supply of water from the soil. In case the soil is dry, what is going to happen? If it's going to create what we call the water stress, and in that case, there's a hormone called abscisic acid, which results in closure of the stomata. This reduces the rate of transpiration, and adequate water supply to the plant is likely to enhance transpiration rate. Then you can look at this graph, rate of transpiration increasing upward, and then here you're having temperature, here you're having humidity, which you have already discussed already. And then I have some other question which you can look at as a wind up, because we are left with about 9 minutes, and then we end our lesson as usual. So there's a graph. This graph, by the way, it has ever been examined in the Waukesha mock. I think it was Waukesha mock. I don't remember the exact year, 2018, something like that, or 2000. Was it 18, 17? I've forgotten a little bit. So the graph shows the rate of transpiration and rate of water uptake of a sunflower plant at different times of day. Okay. After reading that preamble, always come look at this. What is the vertical axis measuring? This is water in grams per hour. And then the horizontal axis is measuring time of day in hours. And then this solid line shows transpiration. And then this one shows a water uptake, the dotted line. And here they're saying for part A says, describe the relation, okay, between this, the two curves. Describe the relation between the two curves. What does this relation suggest? So can I have someone to describe the relation between the two curves? Samsung says that please download for us the graphs. Samsung, next time, please name yourself your proper name. I don't, because I know Samsung is a type of phone, so I don't want to call you Samsung again. Name yourself. What is your real name? So we're saying download for us the graphs. Which graphs? These notes I will put, actually they were them again. Okay, I'll put them again. Emily says, I came across a question saying, what is the effect of abscisic acid in the rate of transpiration now? That's very good that you came across it, and we have just looked at it now. Emily, thank you for that compliment question. So can I have someone to describe the relation between the two curves? Samsung says, my name is Cinderella Normal. Okay, but next time you name yourself Normal Cinderella. Okay, let me choose someone. Yes, Joshua, can you please describe the relation between the two curves? Joshua, you had raised your hand. I'm seeing you are quiet. Okay, let me choose. Hey, I didn't unmute. Joshua, can you please give us the answer?
Yes, teacher.
Yes, please go on.
The relationship between the two curves is that the increase in water uptake, also the increase in water uptake affects the increase in transpiration, in the rate of transpiration, and also the decrease in water uptake also affects the decrease in the rate of transpiration.
Okay, Joshua, now, you see, when you say the increase in rate of transpiration also affects, what is that? That's the relation, how does it affect? That's what we want. Okay, let's find from some other person here, Mildred. Yes, Mildred. Mildred, your voice is extremely low. Mildred, your voice is low. Increase the volume.
And now?
Why you shout the answer?
Hello?
Yes, please. I can hear you now.
Okay, so I was still saying,
yeah,
I'm going to relate to the graph. So
yes,
the rate of
do.
transpiration increases from 6 hours to midday of that. Is it midday? Sorry. Yeah. From 6 hours to 12 hours of that day, due to the increase of light intensity, that increases the rate of transpiration, and transpiration increases the rate of...
Wait, Mildred. Mildred,
Yes.
do you know the meaning of the word to describe?
My God. Oh,
Eh?
sorry.
Yeah. For me, I'm just asking, do you know what it
I
means? I'm not
know.
saying you've done something. Yes. Please
Okay, I'm
describe.
describing.
Mm.
Okay. From 6 hours to 12 hours of the day, the rate of transpiration increases rapidly as the rate of water uptake also increases rapidly. And from 12 hours to 18 hours of the day, the rate of transpiration decreases rapidly as the rate of water uptake still increases gradually. And from 18 hours to 24 hours of the day, the rate of transpiration still decreases rapidly and the rate of water uptake decreases also rapidly. And from 24 hours to 6 hours of that day, the rate of transpiration decreases gradually and the rate of water uptake also decreases gradually.
Okay, thank you. Thank you, Mildred. Let me first comment about something. Now, you guys, to describe means to paint a picture of something in words. When you're describing, you are painting a picture of something in words. You don't have to tell us the reason as to why the graph is either increasing or decreasing. You don't have to tell us why. Okay, when you are describing, you're painting a picture of something in words. Now we are left with 1 minute, Banang. This lesson is normally short, but let me first, here is saying that relate and compare, do they carry the same sense? To relate is actually different from compare. When you are comparing, you are looking at similarities and differences between the two. But when you are relating, you see, does this one have an effect on the other? How are they? Because this is a moving graph, okay? When Mildred was explaining, he had some, of course, some good points, but there is a way she was getting off a little bit, okay? And you guys, I had wanted us to continue because I'm seeing Chisachi has the hand up and all that, but time, our lesson is exactly 30 minutes. Maybe we shall continue from there next time because the lesson has ended. Enjoy yourselves and goodbye. We shall continue from that very number next time. Bye-bye.